Hey everybody, so welcome back. So today we're going to be talking about constructing a fence in my backyard. So what we're going to be doing is we're going to be installing a 6-foot vinyl fence with 5-inch posts. And for the most part, the installation of the fence is going to be pretty straightforward, where you just go use traditional methods where you excavate a hole, put the posts in the hole, and then you fill it with concrete, and then you put the posts into the panels, right? So that's going to be about 85% of the job. There is a unique aspect of everything else, because what it is on the back side of my yard is I have a retaining wall, and what we need to do is we need to come up with some type of surface mount to attach the vinyl post to, because what it is on the back side of the yard, the fence is going to sit on top of the retaining wall, and so we need to figure out a way to do it. So essentially what we're going to do is we're going to talk about the construction of these surface mounts and what I'm going to do and how they're going to be constructed and everything else. So why don't we go ahead and step into the garage, we'll go into a little bit more details, and then we'll actually start making them, and we'll go from there. Alright guys, so this is what we're talking about. So we have the retaining wall, and that retaining wall is made out of 6x6 pressure treated ground contact timbers. And on top of that, we're going to have the base plate. And welded to the base plate, there's going to be a 2-inch steel tube. And then on the tube, there's these mounts, which are 5 inches in diameter. And what they do is they slip over the tube, and it looks like a black donut. And what it is, those mounts are called easy mounts, and they're adjustable on height. And what happens is once this surface mount is attached to the retaining wall, the vinyl post slips right over it, and then you can attach the vinyl post to the easy mount using screws. And then essentially at that point it's locked right in. So why don't we go ahead and we'll go out to the retaining wall, and I'll show you what we're talking about, and we'll get started on the construction of the plates. Alright, so we're out at the retaining wall. So what I did is, just for the sake of demonstration and so things show up a little bit easier, I just painted this plate white. And what I did is the tube that's going to be welded onto this is a 2-inch tube. And so that right now that pencil mark is in the center of the plate. And then you know, that's where the holes are going to be. I'm just going to true those up with some layout lines and go from there, just to give you a reference of how the plates are going to be drilled and everything else. So again, the plate is 4 inches by 4.5 inches on the length, and that's pretty much it. So why don't we go ahead back in the shop, and let's go ahead and start drilling this. Alright, so we're back on the bench. I went ahead and used my combination square and a pencil, connect all the dots, and essentially they're all a 1/2 inch away from the perimeter of the plate all the way around. And then I went ahead and basically spotted all the holes, right? So now we're ready to drill, right? So let's talk about cutting metal, right? So with anything, there's the right way to do it. And cutting metal, you know, some people have a lot of problems with it because they really don't understand cutting surface speeds, RPMs, and drill bits and everything else. So before I got into the industry that I'm in now, I used to do machining and programming for machining centers and everything else. So all I did for 12 hours a day was deal with cutting speeds and surface speeds and RPMs and everything else. So with that being said, before you ever delve into start cutting metal, what you want to do is you want to figure out the surface speed or the cutting speed for the material that you're going to be working with. So for me, we're just using regular hot rolled steel, and the cutting surface speed it varies anywhere from 100 to 200. So what I'm going to do is I'm going to use the low end of the range. I'm going to start with 100, so I don't burn out the cutting edge of the drill. And then you put in the diameter of the drill that you're using. For this, we're using 5/16, which is 0.312 in diameter. And then what it does is it gives you a spindle speed or an RPM. And for this particular instance, it comes right around 1100 RPM. So, but with this Ryobi drill press, It essentially has a range of 1390, so that's what we're going to shoot for, and right now it's in the correct pulley position, so that's what we're going to use. Alright, so, and whenever you drill or cut metal, whether you're drilling it, milling it, whatever, you always want to use some type of cutting fluid, and that's going to really help make things go a lot quicker. For this, I'm just using some thread cutting oil I picked up in the plumbing section. Essentially, it's the same type of fluid that they use to cut threads in a black pipe. But for what we're doing, it's going to be fine. So why don't we go ahead and get started and start drilling some holes, and we'll see how the first plate comes out. Right, so there we go. The first plate's done using cutting fluid. Worked out with no issues. Never stressed the drill or anything like that. Went without any fanfare. So if you're ever wondering if your tools are getting worn or anything like that, the easiest way to check, you'll know as you're going through it. You'll just hear that the drill is struggling or something like that. But even prior to that, if you flip over your work, the biggest way to know that your tool is starting to get ragged is looking at the exit hole on your work material, and if it's really blown out and it's really a big heavy burr on it, that's a very good indication that you need to sharpen your tool or basically change it out or adjust your speeds and feeds, because you're starting to lose the leading edge on your drill bit. Right. So what we're gonna do now is we're gonna essentially mimic this on the remaining 6 other plates, and we're going to get those done and soldier on and keep working. So I'm going to go do that now, and let's go. Right, so after an hour of drilling and taking my time and using cutting fluid, all the plates are done with really no issues at all. So at this point, the next step is to bring them down to the fence supplier, where he's going to take the tubes and weld them to the plates, and then I'll start mounting the surface mounts to the retaining wall and start assembling the fence. So stay tuned for the next step. Probably going to be starting this over Labor Day weekend, and we'll go from there. So if there's any questions, as always, leave them in the comments box. And thanks for watching, and have a great day. Bye.